Here we are for chapter 5. We're going to do the odd numbered exercises that start on page 160. This is page 167 of your textbook. Okay. It looks a little different because I had to copy and paste it from a photocopy, so let's start with number 1. Using the normal curve table. Now, when you go into Moodle, if you don't have it from class, there's a file that says print me normal curve table in section 5. One side has the negative and one side has the positive. Using the normal curve table, determine the area of the standard normal distribution that is between the mean of 0 and the following z-scores. So first things first, bucket on the floor. What do? Well, draw a normal curve. And we would like to find the z-scores that are between the mean of 0 and the z that we're given. Now, a standard normal curve has a mean of 0 and a standard deviation of 1. So we started at 0. If we're given a z-score of 0.69, we are asked to find the area of the curve that is between the mean and this number. So this is the amount that we're looking for here. Does that make sense? If it does, then you know we're going to look up in our z-table 0.69. So let's escape out of here. Pull up our z-table, and we're looking for 0.6, and then we got to go over to the 9th column, which is here at the end. 0.7549, excuse me. So back to our little slideshow. So the area here is 0.7. Oh, I forgot already. This is why it's good to have it printed out. 7549. But let's take a look for a second. If we take a look at the top of our z-table, remember, always look at the picture at the top. The picture at the top shows z that goes all the way back to negative infinity. When we were drawing our sample curve, we were only getting this area between z and 0. So how much area is from 0 back? Well, that's with a z-score of 0, because that's where we started. So let's go back. It's 0.5. So from here back is 0.5000. So I hope everybody understands how I got that. Looking at the z-table, a z of 0.00 has an area under the curve to the left of 0.5. So if I need to find the area that is between these two, I'm going to take 0.7549 and subtract this area here, which is 0.5000, and I'm hopefully going to get 2549. Check the back of the book, and that is how much the area is. If you wanted to, you could write it as 2549. That's the percentage of the area. Hope that makes sense. Let's do another one. Let's do a negative. Make this a little bit more difficult. Let's do a negative. Let's do E. First step, bucket on the floor, draw my normal curve. Question says between 0 and negative 1.86. So I know that from the 0 point backwards that the area under the curve is 0.5000. And now I need to look up on the table a negative 1.86. So here's my standard normal table, z-score. These are all positives. Let's go to the other page. Here's my negatives. Now remember, I need negative 1.86, so it's going to be this column up here. Let's keep our eye on that one. A little too far. 1.8 is this white row going across. 0, 1, 2, 3, 4, 5, 6. Make sure you guys double check. 1.86. 0314. Okay. That's the area from 1.86 back. The question asked me, what is the area between 1.86 and 1? So how much is that? You can just subtract. This is going to be 10, makes this a 9. 10 minus 4 is 6. 9 minus 1 is 8. I need to make this a 10. Oops. Make this a 4. 10 minus 3 is 7. So the difference is 47.86% of the curve. You do one. Let's see. Hit pause and do C. You're supposed to hit pause and then do this on your own. Now that you've done it on your own, let's take a look at C. First step, draw a normal curve. Remember, I'm starting at 0, which from there on back is half of the curve. And I want a positive 2.01. Looking it up on my chart, 2.019778. So that's how much we go from here to here. But I only want this part. I'm going to subtract 5. And the answer was 47.78%. Alright, if you're playing along at home, hit B and hit pause, and do B and D, and then check back in after you unhit pause. Okay, remember, if it's negative, you need to draw this type of curve. If it's positive, we're going to be on that side. Let's look at the next one. Using the normal curve table, determine the area of the standard normal distribution that is greater than the following z-scores. Okay, so we're going to be given a z-score, and it wants the area that is greater than. I'm going to start with C, 2.30. Now the way that our z-table works is it's the area less than z, so it's coming back all the way to the end of the curve. That's the number we're going to get. So how can I calculate what this area is? Well, easy. I know that the total area of the curve is 1. And if I subtract the area that is less than, I'll be left with the area that is greater than. So I'm going to look up in the table, what is a z-score for 2.30? And that is 0.9893. So let's do some simple math. That was a 10. I had to make that a 9. 9 minus 9 is 0. To make that a 10, I have to make this a 9. And that is 0. So how much is in the area of the curve that is greater than 2.30? This area here is equal to 2.07%. Again, I'm just moving the decimal place over to make it a percentage. And that's how much is down here at the bottom of the end of the curve. Let's do one that's in the negative. Let's do E. Ugly curve. I want to know what is greater than a negative 1.34. So from here on back, I have, let's flip the sheet over, negative 1.34. Looking on my table, that's an 0901. So how much is actually over here? I'm going to take 1, and I'm going to subtract the area that I don't want. Oops. Remember how sometimes the simple mistakes? Let's do that again. I'm sorry. 0901. So I'm going to start with 1. Total area of all of the curve. I'm going to remember to write out 4 zeros this time. 10 minus 1 is 9. 9 minus 0 is 9. I'm going to change this 100. Well, let's look at it. 100 minus 9 is 91. So the area under the curve, that is all of this, is 91.99%. Okay. Hit pause, and you need to do A, B, and D. And I'll write the answers. So you've hit pause, and now you're back. And 3A is 21.77. B is 11.12. C we did together. No. C we did together. D is 81.59. We just did E, and E was 99. Okay. Move on. Not sure why all of this is here. See if I can clear the slide. Sorry about that. Sometimes my tablet likes to mess around. Alright. 5. Exercises 5 through 9 are based on the following examples. IQ scores are normally distributed in the population with a mean of 100 and a standard deviation of 16. Use the normal curve table to complete these exercises. Transform the following IQ scores into z-scores. Oh, that's easy. We're going to take our raw numbers here. These are our x's. And remember that z equals x minus mu divided by sigma. So z is going to equal x minus 100 divided by 16. So all we have to do is plug in the x. So let's look at A. 116 minus 100 divided by 16, that equals 16 divided by 16, that equals a z-score of 1. Now this was 16 on the positive side. B, 84, is going to be 16 on the negative side, because 84 minus 100 equals negative 16, which is going to be a negative 1. C, 124 minus 100 divided by 16 equals 24 divided by 16. This is 1 point, it's not quite double, it's 1.5. Let's do D. 95 minus 100 divided by 16 equals a negative 5 divided by 16. I'm going to need to get the calculator out for that one. Negative 5 divided by 16 equals now I got one of these silly calculators where I got to put the parentheses around the negative 5. Alright, let's do 5 divided by 16. That is equal to a negative 0.3125. Now our z-table is only going to go to 2 digits, so this would be a negative 0.31. And finally E, 130. 130 minus 100 divided by 16 equals 30 divided by 16 equals, consult my calculator, 1.875, but remember a z-table only used 2 digits, so it's actually going to be a 1.88. Let's use our same example. Let's not forget that mu equals 100 and sigma equals 16. What percentage of IQ scores is less than 122? Let's do A. First step, bucket on the floor, draw the curve. 122 is actually more than 100. So I need to convert 122 into a z-score. Divided by 16. This z equals 1.375 or 1.38. It's asking for the percentage less than 122. So now I've got this z-score. I'm going to turn it into area by looking it up in the table. 1.3 over to 8 is 9162. So what percentage of scores is less than 122? 91.62%. There we go. Let's do a greater than. Let's do a greater than 112. So first step, bucket on the floor, draw a normal curve. My mean is 100. I need to do greater than 112. So let's do 112. So first step, calculate the z-score. 112 minus 100 divided by 16 equals 12 divided by 16 equals, I believe that's 3/4. Yep, 0.75. So let's look it up in our table. 0.7 over to the 5, 7734. The question was asking me what area is greater than 112. So if I start with a area of 1 and I subtract 7734, I'm not messing around with this. I'm going to use the calculator. 1 minus 0.7734 equals 0.2266. So how much is it that is greater than 112? 22.66%. Hit pause, and when you unhit pause, I'll write down the remainder for B, C, D, and E. Okay, so with B, hopefully you calculated a z-score that was a negative 1.44, which would give you a percentage of 7.49. C, your z-score was 0.25, which gives us a percentage of 59.87%. D, our z-score was equal to 2.19, which gave you a percentage of 95.45. And finally E, we gave you a z-score of negative 1.69, which should result in an area of 95.45. Sorry, looks like I wrote down the wrong number up here. Got a little ahead of myself. That should have been 1.43. Okay, there we go. Here we go, last one. What percentage of IQ scores is less than 110 or greater than 130? Let's not forget mu equals 100, sigma equals 16. Okay. How do we do this? Well, we're actually looking for two percentages, the less than percentage and the greater than percentage. So let's draw our normal curve. Actually, let's do a much bigger one, that way we can really take a look at this. My mean is 100, so that's the center of the curve. And it wants the IQ scores that are less than 110 or greater than 130. So it really does not want this section here between 110 and 130. So let's go ahead and find it. We'll start with the 110. What percentage of IQ scores is less than 110? Well, 110 minus 100 divided by 16 is 10 divided by 16. Grab a calculator real quick. That is equal to 0.625. I'm going to round that to 63. Looking up 0.6 over to 3, that is, this area here is equal to 73, lost it on the chart, 73.57. So that's how much I have here. Now I need greater than 130. So my z-score for 130 table, 1.8 over to the 8 column, 96.99. But remember, that's going backwards. I need to figure out how much is greater than. So 1 minus 0.9699. Cheated and used the calculator, and it tells me that from here forward is 0.301. Okay, now last thing, before we move to the next one, what percentage is less than or greater than? So what I'm actually going to do is add these two numbers together. So this one is 8, 5, and 6. It asks for it as a percentage. So what percentage of IQ scores is less than 110 and greater than 130? 76.58%. Ta-da! So really all this question is asking you to do is to go ahead and find the two z-scores that represent these numbers, and then once you have those numbers, find the area of the curve, draw the curve, and find the area of the curve that is in between those numbers. So find the area of the curve that's less than 110, find what area of the curve is less than 130. If you know what's less than 130, then you also know what's more than 130, and then add those two numbers together. Alright, hit pause and do C. And then when you get back and unhit pause, I'll show you how I did it. So let's do C. First step, draw a normal curve. My mean in my middle is 100. I need to find the area that is less than 95 or greater than 105. I hope something has struck you as odd, right? Because we're both going to be 5 units away from the mean. And if we remember that this distribution is symmetrical, I should only need to find this number, the z-score for this one, because that'll also give me the z-score for this. Again, it's symmetrical. In your mind, take the center line and fold my crude drawing over on top of itself, and we should be finding the exact same area for -5 and +5. So let's go ahead and do the math and prove it. 95 minus 100 divided by 16, -5 divided by 16. Consult my calculator, 0.3125. Yep, just did it twice to double check. Looking up, remember z-scores are to the last 2 digits, so we're going to round -31. Looking at the worksheet, standard normal, turn it over to the negative side, 0.31 is a 3783. So there's 1/2. Less than 95 is 37%. Now if I just added this other 3783, I'm going to get 75.66. So our answer for C is going to be 75.66%. But I still need to prove to you that this is symmetrical. So let's go ahead and calculate our z-score for 105. 105 minus the mu of 100 is 5 divided by the standard deviation of 16. I just did this. 31.25. But remember, we're going to ignore the 25 and we're going to look up a z-score of 0.31. Flip our table over. 0.31 is 62.17. The area of the curve is 1. And we know that less than 105 is 62.17. That leaves look at that. Sometimes math works out so beautifully. Okay, so that is how to fix, how to do C. I'm going to do some erasing, and you hit pause, and then when we come back, I'll give you the answers for B and D that you're going to do on your own, right? Okay, let's do some erasing. So for 9B, you're going to find two z-scores. First, for the negative, should have been 1.25, and then for 90, it should have been negative 0.63. And when you draw your curve and do it right, hopefully you came up with 84.13%. And the last one is D. D is very similar to C, right? Because you're symmetrically 1 unit away, so hopefully your two z-scores were a -1 and a +1, and your percentage total should have been 31.74%. Okay, again, not so hard. Draw the curves and then go from there. We got a new example. For 11 and 13, imagine you're the president of a toy company that builds video games. We've determined that the time needed to build these games is distributed normally with a mean of 20 and a standard deviation of 5. What percentage of the video games is built? Okay, so normal curve. Mean is going to be 20. In less than 15 minutes. 15 minutes, I want the percentage that it's less than. Now, I'm looking at this again quickly. Standard deviation is 5. I know that the z-score for this is 1. It's going to be a -1. Here, I'll do the math to prove it. 15 minus 20 divided by 5 equals -5 divided by 5 is a -1. Okay, so looking up a -1 in my table, 1587. That's the area less than 15. So what percentage of video games? 15.87%. If I were to change this and it says what percentage is built in less than 10 minutes? That's 2 standard deviations away. I know my z-score, is going to be 2. Looking up a -2 on the table. -2 is 0.0228. So in less than 10 minutes, I'm building 2.28% of my video games. 11C, let's take a look at this one. see is in more than 20 minutes. Well, 20 is my mean. So more than 20 minutes is the positive side. How much area is in exactly half of my curve? 50%. Again, if you want me to do the math, I can. 20 minus 20 divided by 5, 0. Take a look at your z table for 0. Either a negative 0 or a positive 0. It tells you that it's half. So if the area from here forward is 0.5, 1 minus 0.5 gives us 0.5. That's the remaining area in the curve. Not so hard. In more than 30 minutes, so I go over here and 30, again that's going to be a z-score of a positive 2, because 30 minus 20 divided by 5 is 10 divided by 5 is 2. Okay. Again, z-scores are changes in x based upon the unit of standard deviation. Alright, I'll do one more that looks kind of hard. Let's do F. F goes on both sides here. This will erase. I'll draw it over here. F wants to know between 12 and 24 minutes. So first I got to find what z-score corresponds with 12. 12 minus 20 divided by 5, negative 8 divided by 5. Let's check the calculator. 8 divided by 5 is negative 1.60. Looking up on my sheet, a negative 1.60, 0548. Okay. 24 was my other one. 24 minus 20 divided by 5. 4 divided by 5, that equals a positive 0.8. Double check real quick on the calculator. Yep, 0.8. Looking up 0.8 on the positive side, 7881. Now the question asked me between 12 and 24 minutes. So how much is the area between these two? So I'm going to take my 7881 and I'm going to subtract my 0548. And I'm going to say that between 12 and 24 minutes, 73.33% of the video games are made. There we go. If you want to do E on your own, hit pause. And the answer for E is 10.69%. Alright, let's look at the next one. Let's end the show and clear all this out so that I can do it again. 90% of the video games are built in blank minutes. Okay, this is new. I haven't shown you this before. Let's do our curve. The average time to build a video game was, well, I forgot already, 20 minutes, standard deviation of 5. Let's think about this. I'm used to being given the mean and the standard deviation and then told what x is for my equation of x minus mu divided by sigma to give me the z-score that I need to look up. And then once I have the z-score, I look it up and then find the percentage. But what would I do if I'm given the percentage to start? I need to find the z-score that corresponds to the 90th percentile. %of the video games are built in how many minutes? So I need to find what z-score gives me an area of 0.90000. Okay, so I'm going to start with my table, and I'm going to look in the field for 0.900. Well, 90%, it's not going to be negative. It's definitely going to be positive. Okay, so I'm looking for 0.9. Well, here's a 0.9, but it's more than 0.9, so I got to go back. I'm going to start 1.2. I really wish I didn't highlight all of those numbers, but let's look here. Oh wow, I'm really messing it up. There, where the little flag is. Okay, I've got two numbers. I've got 1.28, which gives me an area of 0.8997. So I am only 3 away. 3/10,000ths away. This is probably the better one. The other reason is you don't really want to go over, because you're not going to get the 90th percentile if really you're going out beyond the 90th percentile. So I'm going to pick this number. This is going to be the closest one to 0.9 for my 90th percentile. So 1.28. That's what my z-score is going to be, 1.28. Now what is 1.28 standard deviations away? 1.28 times the standard deviation of 5. Get my calculator out. Because remember, z-score are units of standard deviation. So 1.28 times 5. Standard deviations is 6.4. So this is plus 6.4 minutes. So in order to get out here, I have to go out to 26.4 minutes. Now that made sense to me. It made sense doing it that way for me. Let's do this another way. X we know is 20, or excuse me, sorry, X is what we're looking for. Mu is 20 divided by 5. And we know that the answer to this is 1.28. So now you're having flashbacks. This is some serious high school math here, because we've got to solve for X. We got to move these parts around. So how do we move them around? Well, if you want to move something that's division, you have to multiply by it on both sides. So that cancels that out. And then in order to move something that is a negative to the other side, you have to add 20. So X equals 20 plus 1.28 times 5, which is just what I did over here to figure it out. Again, you know all this math. It's about being comfortable enough to process it. 15. Now we're using baseball. Between 1980 and 200, there was a remarkable increase in the number of home runs. A recent article stated that the average number of home runs per game rose from 1.47 in 1980 to 2.34 in 2000. One factor is the ball. One of the responsibilities is to check the weight of baseball. In a recent report, the research center found that the weight of baseballs used in the 2000 season had a mean of 5 ounces with a standard deviation of 0.06 ounces. Major League Baseball specifies that the weight of baseballs should be between 5 and 5.25 ounces. What percentage of the baseballs falls outside of the specified range? That is, what percentage of the 2000 baseballs was less than 5 ounces? What percentage weighed more than the 5.25 ounces? Bucket on the floor, draw a normal curve. What's our mean? Our mean is 5.07 ounces. Our standard deviation was 0.06 ounces. First thing that's going to happen is all of these decimal points are going to make you to cause a mistake. So let's just remember, they're just numbers. Baseball should be between 5. Oh, why'd you do that? And 5.25. What percentage weighed more than 5.25? What weighed less than 5? Okay, so we just convert these to z-scores. That's our z-score 0 because it's our mean. 5.00 minus 5.07 gives us 0.07 negative divided by 0.06. It's going to be 1 something. 0.07 divided by 0.06 negative 1.16, and then it just keeps going. 1.6 repeated. I'm actually going to round that up to 1.17. Okay, 5.25 minus 5.07 divided by 0.06. 0.25 minus 0.07, yep, that's 0.18 divided by 0.06. Hopefully you recognize that is 3. So I'm 3 away. Now, here's the question. What percentage weighs less than? So I got to get my table out. Less than 5 and more than 5.25. So less than a negative, let's find the z table, 1.1, and then over to the 7th column, 0.1210. And positive, I'm going to fold it over, 3. 3.0 is 9987. Now that 9987 is actually this way, so I should have wrote it over here. which leaves how much that is greater than. Well, again, if I subtract it from 1. Okay. What percentage is less than 5? 12.10%, way less than the 5 ounces. And less than 1%, right? If we're going to turn this to a percentage, 0.1%, way more than 5.25 ounces. Bet you didn't know the weight of baseballs could be so boring. Okay, one more. Let's see. Sample of baseballs weighed in 1999 had a mean weight of 5.09 ounces. With a standard deviation of 0.05 ounces. Notice this is a sample, so we're going to switch notation. We're not going to use sigma and mu anymore. We're going to use x bar and s. What percentage of the 1999 baseballs fell outside of the 5 to 5.25 range? Well, I'm going to let you guys hit pause and figure this one out, and then when you come back, I will give you the answers. So for this one, 5 minus 5.09 divided by 0.05, you get a negative 0.09 divided by 0.05. That is going to give you, it's 1.8. Oh, sorry, negative. So that's our z-score here is a negative 1.80. And 5.25 minus 5.09. Let's see, 25 minus 9 is 16, divided by 0.05. That's going to be 3.2. Okay. And then you just look these up. Negative 1.8. Positive 3.2, 3.209993. That leaves 0.0007 in the positive. So less than 3.59% and 0.07% is greater. So I hope that's what you got. What if you took final exams in 2 different courses and have to get the same grade of 72 on both of them? The mean in the 2 courses turns out to be same. However, the standard deviation in the 2 courses differs. S equals 12 in the first course and S equals 6 in the second. Calculate the z-score for your score in both courses. Alright, boss, not a problem. 72 minus 60 divided by, in the first course, it's 12, and 72 minus 60, and the second course is 6. 12 minus 12, 1. 12 divided by 6 is 2. Done. So the z-score for the first course is 1, the second course is 2. Again, once I'm seeing this 6 and 12, 12, right? It's just all sort of units away. Even though your score on the 2 tests was the same and the mean in the 2 courses were the same, why are your 2 scores different from each other? Well, that's easy because z-score is about change in standard deviation units. And so because the standard deviation units are different, z-scores are going to be different. Relative to the other students in the courses, which course would you consider your performance to be better? Why? That's easy. I'm better when I'm further away from the standard deviation. The first test, I was 1 standard deviation unit away, which when I look up a 1 in my table, that's an 8413. So I was in the 84th percentile, whereas if I'm 2 standard deviation units away from the mean, I am 2.0 is 9772. First test, I was in the 84th percentile. Second test, I was in the 97th percentile. I did better in the second course because I was further away from the mean. Okay, really, one more. 2 students are comparing their recent midterm scores. The first student received a 92, and the second one received an 86. However, they're in different classes, and their tests are different. Mean score in the first student's class was 82. So the first student received a 92, and the mean in his class was an 82. The second student received an 86. The mean score in the second student's class was 75, with a standard deviation of 10 in both of the classes. Okay, A, convert both students' scores to z-scores. Not a problem. 10 divided by 10 is z equals 1.00. 86 minus 75 is 11. Z-score here equals 1.10. What percentage of test scores was below each score? Well, if I've got a z-score of 1.0, that's the 8413. And a 1.10, 86.43%. Which student did better on the test? This student did better on the test. He was 11 points above the average. The other student was only 10 points above the average, and they both had the same standard deviation. Okay, please be done. Yay, we're done. Okay, so I hope that walking through these exercises helped you understand z-scores and how to get them. Mostly what we did was think about the distribution in terms of the percentage. What we're going to do next time is take that percentage and think about it in terms of probability. So I hope you're comfortable with the z-score. If not, please go ahead and maybe do some of the even numbered questions. I can go over those with you in office hours if you have any issues. Talk to you next time.